The value of closed integral 3z minus 5 divided by z minus 1 into z minus 2 into dz along a closed path gamma is equal to 4 pi iota, where z is equal to x plus iota y. The correct path gamma is. To solve this problem, we need to use the concept of Cauchy's integral formula and Cauchy's residual theorem. So let's first understand the Cauchy's integral formula. Now, according to Cauchy's integral formula, if f of z is an analytic function, that means it is differentiable everywhere, within and on this closed curve C, and suppose if there is a point z0 inside the C, then we can write the closed integral of f of z divided by z minus z0 is equal to 2 pi iota f of z0. So this is Cauchy's integral formula. Now let's see what is Cauchy's residuals theorem. Now suppose in that same curve C, inside there are some singular points, let's say S1, S2, S3 and others. Okay. So according to Cauchy's residual theorem, the line integral on curve C f of z into dz will be equal to 2 pi iota into summation of residues at the singular point within C. So f of z within C, so let's say z is equal to sk and k belongs to 1, 2, let's say there are n number of singular points. So that's how we write Cauchy residuals theorem. So that's what we know from Cauchy's residual theorem. Now suppose if f of z has a singular pole, has a simple pole at z is equal to a, then we can say the residue of f of a will be equal to limit z tends to a, z minus a into f of z. Now coming to the actual problem. So in the problem it is given the closed integral on the curve gamma 3z minus 5 divided by z minus 1 into z minus 2 into dz is equal to 4 pi iota, which we can also write as 2 pi iota into 2. Let's say this is equation number 2, and let the Cauchy residual theorem this be equation number 1. So if we compare equation number 1 and equation number 2, from here we can see that the sum of residue is equal to 2. Now residue at z is equal to 1, so let's write f of z at z is equal to 1 will be equal to limit z tends to 1, z minus 1, 3z minus 5, this is f of z, divided by z minus 1 into z minus 2. So this we can also write as limit z tends to 1, 3z minus 5 divided by z minus 2. So if we substitute the limit z is equal to 1, we get residue at z is equal to 1 is 2. Okay, now let's calculate residue at z is equal to of f of z at z is equal to 2. So this will be equal to limit z tends to 2, z minus 2 into f of z, that is 3z minus 5 divided by z minus 1 into z minus 2. So this we can also write at limit z tends to 2, these two will get cancelled. So this is 3z minus 5, z minus 1. So if we substitute the limit, we get the residue at z is equal to 2 is 1. Okay. Now the integral over the curve gamma, 3z minus 5 divided by z minus 1 into z minus 2 into dz will be equal to 4 pi iota, which is equal to 2 pi into 2, which is equal to 2 pi iota into residue at f z is equal to 1. Therefore, z is equal to 1 must lie inside C, and z is equal to 2 must lie outside of C. Okay, so let's go back and match with the given options. So from here we can see in option 1 both are inside the curve gamma, and here only 1 is inside gamma and 2 is outside gamma. Therefore option B is the correct choice. To get more information on Cauchy integral theorem or Cauchy residual theorem, you can refer to the NPTEL course lecture number 21, classification of singularities, residue and residual theorem on advanced engineering mathematics by Professor P.D. Srivatsava of the Department of Mathematics at IIT Kharagpur.